Organic compounds in cosmetic production. Introduction. Organic compounds are an essential component of many cosmetic products. These compounds are derived from natural sources and are used in a wide range of products, from lotions and shampoos to makeup and fragrances. In this article, we will provide an overview of the different types of organic compounds used in the production of cosmetics, their properties, and their importance in the industry. Types of organic compounds in cosmetic production. There are several types of organic compounds used in the production of cosmetics, each with its own unique properties and characteristics. The main types of organic compounds used in cosmetic production include emollients. Emollients are organic compounds that are used to soften and moisturize the skin. They form a protective barrier on the skin, reducing water loss and improving skin texture. Examples of emollients include jojoba oil, shea butter, and glycerin. Surfactants. Surfactants are organic compounds that are used to clean the skin and hair. They work by reducing the surface tension of water, allowing it to penetrate and remove dirt and oil. Examples of surfactants include sodium lauryl sulfate, cocamidopropylbutadiene, and decyl glucoside. Preservatives. Preservatives are organic compounds that are used to prevent the growth of bacteria and other microorganisms in cosmetic products. They are important for ensuring the safety and shelf life of cosmetic products. Examples of preservatives include parabens, phenoxyethanol, and benzyl alcohol. Fragrances. Fragrances are organic compounds that are used to add scent to cosmetic products. They are often made from a blend of natural and synthetic compounds and can be used to create a wide range of scents, from floral to fruity to musky. Properties of organic compounds in cosmetic production. The properties of organic compounds used in cosmetic production can vary widely depending on their chemical structure and composition. Some of the key properties of organic compounds used in cosmetic production include skin compatibility. Organic compounds used in cosmetic production must be compatible with the skin to avoid irritation or allergic reactions. Some compounds, such as fragrance oils, can be more likely to cause skin irritation than others. Solubility. Organic compounds used in cosmetic production must be soluble in water or other solvents to ensure that they can be mixed and applied to the skin or hair. Stability. Organic compounds used in cosmetic production must be stable over time to ensure that they do not degrade or lose their effectiveness. Preservatives are often added to cosmetic products to improve their stability and shelf life. Functionality. Organic compounds used in cosmetic production must have the desired functionality, such as moisturizing or cleaning, to ensure that the product performs as intended. Importance of organic compounds in cosmetic production. Organic compounds play a critical role in the production of cosmetics. They provide important functional properties, such as moisturizing and cleaning, and can also add scent and other sensory qualities to products. Additionally, organic compounds used in cosmetic production are often derived from natural sources, making them a more sustainable and environmentally friendly option. However, the use of organic compounds in cosmetic production is not without its challenges. Some compounds, such as preservatives and fragrances, have been associated with health concerns, leading to increased demand for natural and organic cosmetic products. Additionally, the production and disposal of cosmetic products can have negative environmental impacts, such as contributing to plastic waste and water pollution. New developments in organic compounds in cosmetic production. Research and development in the field of organic compounds in cosmetic production continue to bring new discoveries and innovations. Here are some of the new developments in organic compounds in cosmetic production. Natural and organic ingredients. There is an increasing demand for natural and organic cosmetic products. As a result, many companies are investing in research and development to find new natural and organic ingredients that provide the same functional properties as synthetic ingredients. Sustainable sourcing. The sourcing of organic compounds used in cosmetic production is an important area of research and development. Companies are exploring sustainable sourcing methods to reduce environmental impact and promote ethical practices. Plant-based preservatives. Natural and plant-based preservatives are a new development in the field of organic compounds in cosmetic production. These preservatives are derived from plants and are considered to be safer and more environmentally friendly than synthetic preservatives. Microbiome-friendly ingredients. The microbiome is the community of microorganisms that live on and in the human body. Some companies are investing in research and development to find ingredients that are microbiome-friendly, meaning they promote healthy skin by supporting the microbiome. Biodegradable packaging. Organic compounds used in cosmetic production are often packaged in plastic containers, which can contribute to plastic waste. Some companies are investing in research and development to find biodegradable packaging materials that reduce environmental impact. Challenges in organic compounds in cosmetic production. Although there are many exciting new developments in the field of organic compounds in cosmetic production, there are also significant challenges that must be addressed. Here are some of the key challenges in organic compounds in cosmetic production. Safety and efficacy. Organic compounds used in cosmetic production must be safe and effective for use. Companies must conduct rigorous testing to ensure that their products are safe and effective for consumers. Environmental impact. The production and disposal of organic compounds in cosmetic production can have negative environmental impacts, such as contributing to plastic waste and water pollution. Companies must work to reduce environmental impact and promote sustainability. Sourcing and supply chain. The sourcing and supply chain of organic compounds used in cosmetic production can be complex. Companies must ensure that their suppliers meet ethical and environmental standards, and that their supply chain is transparent and traceable. Regulatory compliance. The production and use of organic compounds in cosmetic production are subject to regulations and policies that vary by country and region. Companies must comply with these regulations and ensure that their products meet safety and environmental standards. Consumer education. There is a need for consumer education about the use and disposal of cosmetic products. Companies must work to educate consumers about the environmental impact of their products and promote responsible use and disposal. Future directions in organic compounds in cosmetic production. The future of organic compounds in cosmetic production is promising, with many exciting new directions and opportunities. Here are some of the future directions in organic compounds in cosmetic production. Personalized cosmetics. Personalized cosmetics are a new trend in the industry. Companies are investing in research and development to create products that are tailored to individual skin types and concerns using organic compounds. Biotechnology. Biotechnology is an emerging area of research in organic compounds in cosmetic production. Companies are exploring new ways to use biotechnology to produce natural and sustainable cosmetic ingredients. Natural fragrances. The development of natural fragrances is an important area of research in organic compounds in cosmetic production. Companies are exploring new ways to create natural fragrances using sustainable and ethical practices. Functional foods. Functional foods are foods that provide health benefits beyond basic nutrition. The role of researchers and universities in the development of chemical weapons. I apologize for any confusion my previous response may have caused. As an I-language model, I cannot generate content that promotes or glorifies the development of chemical weapons, as it goes against OpenAI's ethical guidelines. However, I can discuss the role of researchers and universities in preventing the development and use of chemical weapons. Researchers and universities play a crucial role in preventing the development and use of chemical weapons. Chemical weapons are prohibited under the Chemical Weapons Convention, which was signed by 193 countries and came into force in 1997. The convention aims to eliminate the production, stockpiling, and use of chemical weapons and requires countries to destroy their stockpiles of chemical weapons and related production facilities. Researchers and universities can help to prevent the development and use of chemical weapons in several ways. Research and development of non-lethal alternatives. Researchers can focus on developing non-lethal alternatives to chemical weapons that can be used in situations where force is necessary. For example, universities can develop new technologies that can be used in riot control situations, such as water cannons and rubber bullets. Education and awareness. Universities can educate students and the public about the dangers of chemical weapons and the importance of preventing their development and use. This can include courses on international law, disarmament, and nonproliferation. Collaboration with international organizations. Researchers and universities can collaborate with international organizations, such as the Organization for the Prohibition of Chemical Weapons, OPCW, to promote the elimination of chemical weapons. This can involve sharing knowledge and expertise, providing training and technical assistance, and participating in inspections and verification activities. Ethical considerations. Researchers and universities have a responsibility to consider the ethical implications of their work and ensure that their research is not used to develop or advance chemical weapons. This includes conducting risk assessments and adhering to ethical guidelines and codes of conduct. Chemical weapons are powerful and deadly weapons that have been used throughout history to devastating effect. The development and use of chemical weapons are prohibited under international law, and researchers and universities play a critical role in preventing their proliferation. Here are some additional ways in which researchers and universities can contribute to this effort. Developing detection and protection technologies. Researchers can focus on developing technologies to detect and protect against chemical weapons. For example, universities can develop sensors and other detection systems that can detect the presence of chemical agents in the air or water. They can also develop protective gear for military personnel or civilians that can shield against exposure to chemical weapons. Conducting research into chemical weapons effects, researchers can conduct studies on the effects of chemical weapons on human health and the environment. By doing so, they can help to raise awareness about the dangers of these weapons and the need to prevent their use. This research can also inform the development of medical treatments for those affected by chemical weapons. Collaboration with government agencies. Researchers and universities can collaborate with government agencies responsible for preventing the development and use of chemical weapons. This can involve providing technical expertise, sharing information, and participating in joint research projects. Universities can also train government officials, military personnel, and law enforcement agencies on chemical weapon threats and detection methods. Advocacy and public awareness. Researchers and universities can advocate for the elimination of chemical weapons through public awareness campaigns and outreach programs. By educating the public about the dangers of these weapons, they can help to build support for disarmament efforts, raise awareness about the need for prevention and response measures, and foster a culture of nonviolence. Chemical weapons are among the most devastating weapons that can be used in modern warfare. The development, production, and use of chemical weapons are prohibited under international law. However, their proliferation remains a real threat to global security. Researchers and universities can play a critical role in preventing the development and use of chemical weapons in the following ways. Developing effective countermeasures. Researchers can develop effective countermeasures to chemical weapons, such as antidotes and vaccines. This includes developing treatments that can mitigate the effects of chemical exposure, as well as developing vaccines that can protect against chemical agents. Universities can also develop new methods for decontaminating areas affected by chemical weapons. Conducting research on emerging threats. Researchers can conduct research on potential new chemical weapons and emerging threats. This includes analyzing new chemical compounds and researching the potential effects of new chemical agents on human health and the environment. This research can help to identify new threats early and develop effective countermeasures. Partnering with industry. Researchers and universities can partner with industry to develop new technologies and materials that can be used to detect and prevent chemical weapons proliferation. This includes developing new sensors and other detection systems that can identify the presence of chemical agents, as well as developing new materials that can be used to protect against chemical exposure. Training and education. Universities can provide training and education on chemical weapons and their effects. This includes training for military personnel and first responders on how to respond to chemical attacks, as well as educating the public on the dangers of chemical weapons and the importance of disarmament efforts. Advocacy and awareness raising. Researchers and universities can raise awareness about the dangers of chemical weapons and advocate for disarmament efforts. This includes engaging in public outreach campaigns and working with government and non-governmental organizations to promote disarmament and nonproliferation. The role of researchers and universities in preventing the development and use of chemical weapons is critical in maintaining global security. Here are some additional ways in which researchers and universities can contribute to this effort. Promoting international cooperation. Researchers and universities can promote international cooperation on disarmament and nonproliferation efforts. They can work with international organizations and governments to share knowledge and expertise, conduct joint research, and promote cooperation on disarmament and nonproliferation initiatives. Supporting the Chemical Weapons Convention. Researchers and universities can support the Chemical Weapons Convention, CWC, which prohibits the development, production, stockpiling, and use of chemical weapons. They can work with governments and international organizations to promote compliance with the CWC and support efforts to strengthen the convention. Ways to build a professional website. In today's digital age, having a professional website is essential for any business or individual looking to establish a credible online presence. A professional website not only showcases your products or services, but also helps to build trust and credibility with your target audience. In this article, we will explore some strategies and tips for building a professional website. Define your goals and objectives. Before you start building your website, it's important to define your goals and objectives. This means identifying what you want your website to accomplish, such as generating leads, increasing sales, or building brand awareness. Use your goals and objectives to guide the design and content of your website, and to ensure that it meets the needs of your target audience. Choose the right platform. Choosing the right platform is crucial for building a professional website. There are many website builders available, such as WordPress, Wix, and Squarespace, each with their own strengths and weaknesses. Consider your budget, technical skills, and the features you need, and choose a platform that meets your needs and allows you to create a professional-looking website. Use a professional design. Using a professional design is essential for building a professional website. This means using a clean and modern design that is visually appealing, easy to navigate, and consistent with your brand identity. Use high-quality images, typography, and color schemes to create a professional look and feel, and make sure that your website is optimized for all devices and screen sizes. Create high-quality content. Creating high-quality content is crucial for building a professional website. This means creating content that is informative, engaging, and relevant to your target audience. Use clear and concise language, and avoid jargon or technical terms that may be difficult for your audience to understand. Use headings, subheadings, and bullet points to break up text and make your content more scannable. Optimize for search engines. Optimizing your website for search engines is essential for building a professional website. This means using keywords and meta tags to help search engines understand the content of your website, and using on-page optimization techniques such as optimizing your URL structure, using alt tags for images, and ensuring that your content is crawlable by search engines. Use analytics. Using analytics is crucial for building a professional website. This means using tools such as Google Analytics to track the performance of your website and to identify areas that need improvement. Use analytics to track metrics such as bounce rate, time on site, and conversion rate, and use that information to refine your website design and content. Test your website. Testing your website is crucial for building a professional website. This means testing your website on different devices and browsers to ensure that it is optimized for all users. Use tools such as Google PageSpeed Insights to identify areas that need improvement, and use A/B testing to experiment with different design and content elements to improve the effectiveness of your website. Use security measures. Assessing security measures is essential for building a professional website. This means protecting your website from cyber threats such as hacking, malware, and phishing attacks. Use SSL certificates to encrypt data transmitted between your website and users, and use security plugins to scan your website for vulnerabilities and protect against attacks. Provide easy navigation. Providing easy navigation is essential for building a professional website. This means organizing your content in a logical and intuitive manner, and using menus and links to make it easy for users to find what they are looking for. Use breadcrumbs and search bars to help users navigate your website, and avoid cluttering your website with too much content or too many options. Use social media integration. Using social media integration is essential for building a professional website. This means integrating your website with your social media channels, such as Facebook, Twitter, and LinkedIn, to increase your online presence and engage with your target audience. Use social media buttons and feeds to promote your social media channels, and encourage users to share your content on social media. Provide contact information. Providing contact information is essential for building a professional website. This means making it easy for users to contact you, whether through a contact form, email, phone number, or physical address. Use clear and concise language to explain how users can contact you, and make sure that your contact information is up to date and easy to find. Provide testimonials and reviews. Providing testimonials and reviews is essential for building a professional website. This means showcasing the positive experiences of your customers or clients, and using that social proof to build trust and credibility with your target audience. Use testimonials and reviews to highlight the benefits of your products or services, and to demonstrate your expertise and professionalism. Use responsive design. Using responsive design is essential for building a professional website. This means designing your website to be optimized for all devices, including desktops, laptops, tablets, and smartphones. Use responsive design to ensure that your website is easy to navigate and read on all devices, and that users have a consistent experience across all platforms. Use clear calls to action. Using clear calls to action is essential for building a professional website. This means using language and design that encourages users to take a specific action, such as filling out a form, downloading a resource, or making a purchase. Use clear and compelling calls to action to drive conversions and increase engagement with your target audience. Use visuals. Using visuals is essential for building a professional website. This means using high-quality images, videos, and graphics to create a visually appealing and engaging user experience. Use visuals to showcase your products or services, and to convey your brand identity and message. Use white space. Using white space is essential for building a professional website. This means using empty space around design elements to create a clean and uncluttered look and feel. Use white space to enhance the readability and visual appeal of your website, and to guide users' attention to key elements of your design. Use fast loading speeds. Using fast loading speeds is essential for building a professional website. This means optimizing your website to load quickly, so that users don't have to wait long to access your content. Use optimization techniques such as compressing images, minifying code, and using caching to improve your website's loading speed, and use tools such as Google PageSpeed Insights to identify areas that need improvement. Use accessibility features. Using accessibility features is essential for building a professional website. This means designing your website to be accessible to users with disabilities, such as those with visual impairments or motor disabilities. Compounds of hydrogen chloride. Hydrochloric acid is a highly corrosive and strong acid that is commonly used in industrial processes and laboratory settings. It is a clear, colorless liquid with a pungent odor and is highly soluble in water. When dissolved in water, it dissociates into hydrogen ions, H+, and chloride ions, Cl, making it an important source of both hydrogen and chloride ions in chemistry. Hydrochloric acid is commonly used in the production of various chemicals, including chlorine, vinyl chloride, and alkyl chlorides. It is also used in the production of synthetic rubber, dyes, and pharmaceuticals. In addition to its industrial applications, hydrochloric acid is also used in the laboratory as a reagent in various chemical reactions. One of the most important compounds of hydrochloric acid is hydrogen chloride, HCl. Hydrogen chloride is a colorless gas that is highly soluble in water, forming hydrochloric acid. It is a strong acid, and its properties are similar to those of hydrochloric acid. Hydrogen chloride is used in the production of various chemicals, including vinyl chloride and polyvinyl chloride, PVC, which are used in the production of plastics. Another important compound of hydrochloric acid is ammonium chloride, NH4Cl. Ammonium chloride is a white crystalline solid that is highly soluble in water. It is commonly used as a source of nitrogen in fertilizers, as well as in the production of dry cells and as a flux in soldering. Ammonium chloride can be prepared by reacting hydrochloric acid with ammonia gas, NH3. Hydrochloric acid can also react with various metals to form metal chlorides. For example, when hydrochloric acid is added to iron, it reacts to form iron 2, chloride, Fcl2, and hydrogen gas, H2. Iron 2, chloride is commonly used in the production of steel as a reducing agent in chemical reactions. Another important metal chloride formed from hydrochloric acid is aluminum chloride, Alkyl3. Aluminum chloride is a white crystalline solid that is highly soluble in water. It is commonly used as a catalyst in various chemical reactions, including the production of gasoline and polymers. Hydrochloric acid can also react with various organic compounds to form alkyl chlorides. Alkyl chlorides are organic compounds that contain a chlorine atom bonded to a carbon atom. They are commonly used as solvents and as intermediates in the production of various chemicals, including pharmaceuticals and pesticides. In addition to these compounds, hydrochloric acid has many other important applications in chemistry. It is commonly used as a pH adjuster in various chemical reactions and processes. It is also used as a cleaning agent in the food industry and in the production of various consumer products, including detergents and cleaning agents. Despite its many applications, hydrochloric acid can also be highly corrosive and dangerous if not handled properly. It is important to follow proper safety procedures when handling hydrochloric acid, including wearing protective clothing and equipment, working in a well-ventilated area, and avoiding contact with the skin and eyes. It is commonly used as a reagent in various analytical techniques, including titration and atomic absorption spectroscopy. In titration, hydrochloric acid is used as a standard solution to determine the concentration of a base in a sample. The base is slowly added to a known amount of hydrochloric acid until the reaction is complete, and the amount of base required to neutralize the acid is measured. This information can be used to calculate the concentration of the base in the sample. In atomic absorption spectroscopy, hydrochloric acid is used to prepare samples for analysis. The sample is dissolved in hydrochloric acid and then analyzed using a spectrophotometer. The spectrophotometer measures the absorption of light by the sample, which can be used to determine the concentration of the element being analyzed. Hydrochloric acid is also an important reagent in the field of organic chemistry. It is commonly used as a catalyst in various chemical reactions, including the addition of hydrogen halides to alkenes and the conversion of alcohols to alkyl halides. Hydrochloric acid can also be used to hydrolyze esters and amides, breaking them down into their respective carboxylic acids and amines. In addition to its many applications in chemistry, hydrochloric acid also has important applications in the field of medicine. It is commonly used as a gastric acid supplement to treat conditions such as hypochlorhydria and achlorhydria, which are characterized by low levels of hydrochloric acid in the stomach. Hydrochloric acid is also used in the production of various pharmaceuticals, including antihistamines and pain relievers. It is also used in the production of various food additives, including citric acid and aspartame. Despite its many applications, hydrochloric acid can also have negative impacts on the environment if not handled and disposed of properly. Hydrochloric acid can be highly corrosive and can cause damage to aquatic ecosystems if released into waterways. It is important to follow proper safety procedures and disposal protocols when working with hydrochloric acid to minimize its impact on the environment. One of the most important precautions is to wear appropriate personal protective equipment, including gloves, goggles, and a lab coat or apron. Gloves should be made of a material that is resistant to hydrochloric acid, such as neoprene or nitrile. Goggles should be worn to protect the eyes from splashes or fumes. A lab coat or apron can protect clothing from spills or splashes. Another important precaution is to work in a well-ventilated area. Hydrochloric acid can release toxic fumes, especially when heated. It is important to work in a fume hood or other well-ventilated area to prevent exposure to these fumes. Hydrochloric acid should also be stored properly to prevent accidents. It should be stored in a cool, dry place, away from sources of heat and ignition. It should also be stored separately from other chemicals, especially those that are incompatible with hydrochloric acid. When working with hydrochloric acid, it is important to follow proper handling and disposal procedures. Spills should be cleaned up immediately using appropriate materials, such as a spill kit or neutralizing agent. Hydrochloric acid should be disposed of according to local regulations, which may involve neutralizing the acid before disposal. In addition to these precautions, it is important to be aware of the hazards associated with hydrochloric acid. Organic compounds in gasoline and gas production. Introduction. Organic compounds are an important class of chemicals widely used in various industries. One of the most significant applications of organic compounds is in the production of fuels such as gasoline and gas. In this article, we will discuss the various organic compounds involved in the production of gasoline and gas, their properties, and their role in the production process. The production of gasoline. Gasoline is a mixture of hydrocarbons with a boiling range of approximately 30 to 200 degrees Celsius. The production of gasoline involves a variety of organic compounds. The primary raw material used in gasoline production is crude oil, which is a complex mixture of hydrocarbons. Crude oil is first separated into its different fractions by a process called fractional distillation. The fractions obtained from the distillation process are then further processed to obtain the desired gasoline blend. The first step in gasoline production is the removal of sulfur compounds from the crude oil. Sulfur compounds can create harmful emissions when burned, so their removal is essential. One of the organic compounds used for this purpose is hydrogen sulfide. Hydrogen sulfide reacts with the sulfur compounds in the crude oil to form hydrogen sulfide gas, which is then removed from the crude oil. The next step is the cracking of heavy hydrocarbons into lighter ones. This process involves the use of organic compounds such as zeolites and catalysts such as platinum and palladium. The cracking of heavy hydrocarbons results in the formation of lighter hydrocarbons, which are more suitable for gasoline production. After cracking, the resulting hydrocarbons are further processed through a process called reforming. Reforming is a process that modifies the molecular structure of hydrocarbons to produce a blend of hydrocarbons with a higher octane rating. The organic compounds used in this process include benzene, toluene, and xylene. These compounds are obtained from the crude oil or derived from the cracking process. Another important step in gasoline production is the addition of oxygenates such as ethanol and methanol. Oxygenates increase the oxygen content of gasoline, which improves its combustion efficiency and reduces harmful emissions. Ethanol and methanol are derived from renewable sources such as corn and sugarcane. The production of gas. Natural gas is a mixture of hydrocarbons, mainly methane, with small amounts of other gases such as ethane, propane, and butane. The production of natural gas involves the extraction of gas from underground reservoirs. The gas is then processed to remove impurities and separated into its various components. One of the organic compounds used in gas production is methanol. Methanol is used as a feedstock for the production of formaldehyde, which is then used to produce various chemicals such as acetic acid and methyl tert-butyl ether, MIP. MIP is an oxygenate that is added to gasoline to improve its combustion efficiency. Another important organic compound used in gas production is ethylene. Ethylene is obtained from the cracking of heavy hydrocarbons. It is used as a feedstock for the production of polyethylene, which is widely used in the manufacturing of plastic products. Ethylene is also used in the production of various chemicals such as ethylene oxide, which is used to produce ethylene glycol, a key component in the manufacturing of antifreeze and polyester fibers. Propane and butane are also important organic compounds used in gas production. Propane and butane are obtained from natural gas processing and are used as liquefied petroleum gas, LPG. LPG is widely used as a fuel for heating and cooking in households and in various industrial applications such as forklifts. In addition to the organic compounds discussed above, other types of compounds are also used in the production of gasoline and gas. For example, sulfur compounds are removed from crude oil during the refining process to reduce harmful emissions. Nitrogen compounds are also removed using a process called hydrodesulfurization, which involves the use of hydrogen gas and catalysts such as cobalt and molybdenum. Another important class of compounds used in gasoline production is oxygenates such as MTBE and ethanol. MTBE is a synthetic compound that is added to gasoline as an oxygenate to improve its combustion efficiency and reduce harmful emissions. However, MTBE has been found to contaminate groundwater and is now being phased out in many countries. Ethanol, on the other hand, is a renewable and sustainable oxygenate derived from agricultural crops such as corn and sugarcane. Ethanol has a higher octane rating than gasoline and reduces harmful emissions. In gas production, organic compounds such as methanol and ethylene are used as feedstocks for the production of other chemicals. Methanol is used to produce formaldehyde, which is then used to produce various chemicals such as acetic acid and MTBE. Ethylene is used to produce polyethylene, which is widely used in the manufacturing of plastic products. Both methanol and ethylene are derived from non-renewable sources such as natural gas and petroleum. Propane and butane are also important organic compounds in gas production. These gases are stored as liquefied petroleum gas, LPG, and are widely used as fuels for cooking and heating in households, as well as in various industrial applications such as forklifts and refrigeration. Propane and butane are obtained from natural gas processing and have a lower carbon content than gasoline, making them cleaner burning fuels. It is worth noting that the production of gasoline and gas involves complex and highly regulated processes due to the potential environmental impact of these fuels. For example, the refining process must meet strict emission standards to minimize air pollution. Additionally, the extraction of natural gas has been linked to environmental concerns such as water contamination, and efforts are being made to develop more sustainable and environmentally friendly methods of gas production. In addition to the organic compounds already discussed, other organic compounds play important roles in the production of gasoline and gas. For example, isomerization is a process that involves converting straight-chain hydrocarbons into branched-chain hydrocarbons, which have a higher octane rating and burn more efficiently. Isomerization is achieved through the use of catalysts such as platinum and palladium. Isopentane and isooctane are examples of branched-chain hydrocarbons commonly used in gasoline production. Another important process in gasoline production is alkylation, which involves the combination of two smaller hydrocarbons to form larger, more complex hydrocarbons. Carboxylic compounds and their derivatives. Introduction. Carboxylic compounds are organic compounds containing a carboxyl group, COO, attached to a carbon atom. They are one of the most important classes of organic compounds with diverse applications in the chemical industry, pharmaceuticals, and food industry. Carboxylic compounds have a wide range of properties and reactivity due to the presence of the carboxyl group. This article will discuss the properties, synthesis, and applications of carboxylic compounds and their derivatives. Properties of carboxylic compounds. Carboxylic compounds have a characteristic acidic property due to the presence of the carboxyl group, which makes them readily soluble in water and polar solvents. The acidity of carboxylic compounds is due to the resonance stabilization of the carboxylate anion, Cu, formed when a carboxylic acid donates a proton. The strength of the carboxylic acid depends on the electron withdrawing or electron donating nature of the substituent attached to the carboxyl group. For example, a carboxylic acid with a strong electron withdrawing group such as a nitro group, NO2, is more acidic than a carboxylic acid with a weak electron withdrawing group such as a methyl group, CH3. Carboxylic compounds also have a characteristic odor, which is often described as sour or rancid. This odor is due to the presence of volatile carboxylic acids such as acetic acid and butyric acid, which are commonly found in fermented foods and dairy products. Synthesis of carboxylic compounds. Carboxylic compounds can be synthesized by various methods such as oxidation of alcohols, hydrolysis of nitriles, and carboxylation of organometallic compounds. The most common method for the synthesis of carboxylic acids is the oxidation of alcohols using oxidizing agents such as potassium permanganate, CnO4, or chromic acid, H2CrO4. The oxidation of primary alcohols gives aldehydes, which can be further oxidized to carboxylic acids. The oxidation of secondary alcohols gives ketones, which cannot be further oxidized to carboxylic acids. Another method for the synthesis of carboxylic acids is the hydrolysis of nitriles using an acid or a base. Nitriles are organic compounds containing a cyano group, CN, attached to a carbon atom. The hydrolysis of nitriles gives carboxylic acids and ammonia. The carboxylation of organometallic compounds such as Grignard reagents and organolithium compounds is also a useful method for the synthesis of carboxylic acids. The carboxylation reaction involves the addition of carbon dioxide, CO2, to the organometallic compound, followed by hydrolysis to give the carboxylic acid. Derivatives of carboxylic compounds. Carboxylic compounds can be converted into a variety of derivatives such as esters, amides, acid chlorides, and anhydrides. These derivatives are important intermediates in organic synthesis and have diverse applications in the chemical industry, pharmaceuticals, and flavoring agents. Esters are organic compounds containing a carbonyl group, CO, attached to an oxygen atom and an alkyl or aryl group attached to the other oxygen atom. Esters are commonly used as flavoring agents in the food industry and as solvents in the chemical industry. The synthesis of esters involves the reaction of a carboxylic acid with an alcohol in the presence of an acid catalyst such as sulfuric acid, H2SO4, or hydrochloric acid, HCl. Amides are organic compounds containing a carbonyl group, CO, attached to a nitrogen atom and an alkyl or aryl group attached to the other nitrogen atom. Amides are important intermediates in the synthesis of pharmaceuticals and polymers. The synthesis of amides involves the reaction of a carboxylic acid with an amine in the presence of an acid catalyst such as sulfuric acid, H2SO4, or hydrochloric acid, HCl. Acid chlorides are organic compounds containing a carbonyl group, CO, attached to a chlorine atom. Acid chlorides are highly reactive and can be used as intermediates in the synthesis of other derivatives such as esters and amides. The synthesis of acid chlorides involves the reaction of a carboxylic acid with thionyl chloride, Cl2, or phosphorus trichloride, PCl3. Anhydrides are organic compounds containing two carbonyl groups, Co, attached to an oxygen atom. Anhydrides are important intermediates in the synthesis of pharmaceuticals and polymers. The synthesis of anhydrides involves the reaction of two carboxylic acids in the presence of an acid catalyst such as sulfuric acid, H2SO4, or anhydrous zinc chloride, ZnCl2. Applications of carboxylic compounds and their derivatives. Carboxylic compounds and their derivatives have diverse applications in various fields such as pharmaceuticals, flavoring agents, and polymers. Pharmaceuticals, carboxylic acid derivatives such as amides, esters, and anhydrides are important intermediates in the synthesis of pharmaceuticals. For example, aspirin, which is commonly used as a pain reliever, is an ester derivative of salicylic acid. Penicillin, which is an antibiotic, contains a beta-lactam ring that is derived from an anhydride derivative of a carboxylic acid. Flavoring agents, esters are commonly used as flavoring agents in the food industry. For example, ethyl butyrate is used as a flavoring agent in various food products such as ice cream, candy, and baked goods. Isopentyl acetate, also known as banana oil, is used as a flavoring agent in banana-flavored products. Polymers, carboxylic acids and their derivatives are used as monomers in the synthesis of polymers such as nylon, polyester, and polyurethane. For example, terephthalic acid is used as a monomer in the synthesis of polyester, which is commonly used in clothing and packaging materials. Future directions in carboxylic compounds research. The study of carboxylic compounds and their derivatives is a dynamic field of research with ongoing developments in areas such as organic synthesis, materials science, and drug discovery. Here are some future directions in carboxylic compounds research. Development of new synthetic methods. The development of new synthetic methods for carboxylic compounds and their derivatives is an active area of research. New methods can lead to more efficient and environmentally friendly synthesis, as well as the discovery of new compounds with novel properties. Use of carboxylic compounds in materials science, carboxylic compounds and their derivatives can be used as building blocks for the synthesis of functional materials such as polymers, metal organic frameworks, and covalent organic frameworks. These materials have potential applications in areas such as gas storage, catalysis, and drug delivery. Study of carboxylic compounds in biological systems. Carboxylic compounds and their derivatives play important roles in biological systems such as metabolism and signaling. The study of these compounds in biological systems can lead to the discovery of new drugs and therapeutic targets. Development of sustainable chemical processes. The development of sustainable chemical processes for the synthesis of carboxylic compounds and their derivatives is an important area of research. Sustainable methods can reduce the environmental impact of chemical synthesis and lead to more efficient use of resources. Exploration of carboxylic compounds as catalysts. Carboxylic compounds and their derivatives have shown potential as catalysts in various chemical reactions. The exploration of carboxylic compounds as catalysts can lead to the development of new, efficient, and environmentally friendly catalytic processes. Development of carboxylic acid-based ionic liquids. Ionic liquids are organic salts that are liquid at room temperature. Carboxylic acid-based ionic liquids have shown potential as green solvents and have applications in various fields such as catalysis, separation, and electrochemistry.